Ah, welcome back to another video. Today, you've probably already read from the title, we're going to be doing a little bit of complicated, technical, complicated, professional geometry and other math. I picked a specific section for us to do. This is what professional professors and doctors like me do when they're behind the scenes, and I'm going to bring it out into the scene. I guess I'll do that. So now, what we are going to do before we get into all these tough questions that I will be working out, we must learn the content that is described in here. We will need some writing utensils, obviously. Oh, my glove is not completely... There we go. Writing utensils. Alright. The pencil. And now we also need an eraser. I do not have a good eraser. This will be good enough. I will... No, this is not a good eraser. This is a good eraser. Okay. It's small, but it's humble. And humble is always better than the big. Of course, we need a professional scientific calculator. Look at this. It even graphs. It already has some previous calculations. As you can see, previous calculations that I've calculated with. But that won't matter for now. We also need our paper, which we will use that later when we start actually doing the exercise. And we also won't need this now too. Also, we will be using a reference manual or cheat sheet. Makes a nice papery rubbing sound. Quite tingly, if you asked me. We won't be all needing this now. Actually, we only need the textbook to learn the material before we actually go in. Okay, perpendiculars and bisectors. You can just listen in, we'll learn this together. If you don't like learning, you can still just listen to me talking. In lesson 1.5, you learned that a segment, a bisector, intersects a segment at its midpoint. I had a slight interruption with my pet cat. She was meowing at the door. Where were we? Yes. So this is what a segment bisector is. Do you see the diagram right here? So this is a line segment. A line segment is a finite line with two endpoints, and a segment bisector bisects that line perfectly in the middle, creating two lines that are equal, or at its midpoint. So a segment, ray, line, or plane that is perpendicular to a segment at its midpoint is called a perpendicular bisector. So a normal bisector can intersect any way, can intersect this way, can intersect this way. But a perpendicular bisector can intersect this way. 90 degrees, 5.1. Oh, this is where we get into the theorems. I have recorded every single theorem in this book, in this cheat sheet, but this cheat sheet is very valuable, but we will not be looking at our cheat sheet just yet. If a point on the perpendicular bisector of a segment then if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So, basically, what that means is, so here we have a line, right? Then we have the perpendicular bisector, the line, the second line. So we first have a line segment, and then we have a infinite line, which is the bisector. If you have a point on anywhere on this perpendicular bisector line, it can be all the way down here, it can be up here. I'm not sure the camera catches that, but you can have it anywhere. The amazing thing is that, here, let me bring it up to you. Is that, see these blue lines? This line right here and this line right here, they will always be the same length no matter what. That's just amazing. And someone discovered that, and that is like a beautiful math theorem. It's just mind-boggling. Now, we move on. Okay, this is a bunch of other stuff. Theorem 5.3. There are more theorems. The angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from two sides. Let's say angle BAC. BAC, which means there's sides B that extend out and C that extend out, and then A is the, I don't know, it's like the midpoint, the meeting point of the angle. Then, if there's a line D, which is the angle bisector, then if two lines that are perpendicular to point B and point C, if they both meet at D, then that means these two lines, DC and BD, would be the same, which is amazing. That is a pretty interesting theorem. Yeah, I can start working on the exercises now. Enough chit chat. Let's get into the real stuff. All right. It starts right here. We'll be doing a few problems at the beginning, a few problems maybe midway, and then we're going to do, for the finale, one of these proofs. Proofs are scary, even for professional professors. So, are you ready to take on the challenge? Let's get started. So, our necessary supplies will be our cheat sheet, which we will put here. I don't think you can see the cheat sheet, but it's right here. Next, we will have a pen and pencil. We'll have a paper, of course. And let's go to logical reasoning, number 9. We're getting tougher. To whenever the information in this diagram allows you to conclude that C is on the perpendicular bisector of AB. Okay, perpendicular bisector. Number 9. So the diagram shows there's A, there's B, okay, then there's C. Now we have to depict out of this, if there's enough information to prove that this line is a perpendicular bisector to AB. Okay, at first glance. Okay, so all of these are similar. At first glance, they don't look perpendicular, but that might just be like a visual thing to trick your eyes. That's all. They sometimes do that in geometry just to mess you up. So, we know that each of these are equal. So, if these two, if A, P, and PB are equal, then this would have to be in the middle, which means it would be bisecting in the middle, which would mean it's a bisector. But we don't know if it's perpendicular. There are no angles to show that it's a perpendicular bisector, so I'm going to say no. Because P does not equal, well, the measure of P does not equal 90. Well, we don't know if it equals, so we're just going to say it does not equal 90 because we do not know. Alright. Okay, interesting. We are getting the hang of this. Hopefully I do not forget any vocabulary as I did in the previous questions. I haven't done my proof yet. Oh man, I'm already tired. I'm already worked out, but I'm gonna do a proof for you guys. A full-on proof. Right. I have a clean slate of paper for our proof. We are gonna be doing 29. Complexity. Use the diagram shown to write a to confirm proof of theorem 5.2. The converse of the perpendicular bisector theorem. Okay, so we have to prove 5.2. That's where our cheat sheet comes into play. Yes, let's go back in time to 5.2. In a plane, a point is on the perpendicular bisector of a segment if it is equidistant from the endpoints of the segment, and then the converse of that. So, they want us. C is the perpendicular bisector of AB. That is, make a 2-column paragraph, or 2-column proof. Yes, we are given that CA equals CB. Yes. Good. Okay. Then P equals, well, P is the measure of P equals 90 degrees. Let's straighten that up. Alright. Let us plan our proof. Use the perpendicular postulate to draw CB, AB, so that, okay. I think I have my own method. Alright, let's draw this out. C, B, A, P. C, B, A, P. Oops. A, P. Alright. This video took a lot more work than most videos, so I wouldn't. It would help if you would like, comment, and subscribe, because this is hard work. This is very hard work. Okay, so these are equal. They don't look equal, but they are. It's just my drawing is not top notch. I am not an artist. I'm a professor. Alright. Okay. Now, let's get into proving. So, first of all, we know we need 2 components to verify that this is a perpendicular bisector. First, we need that this is a right angle, which we already have. That is a check. But then we have an x2 because we do not know if AP and PB are congruent, and that's what we need to find. So we know that these are congruent. And also, here's another cool trick. We know that these are congruent too. This line is congruent to itself. I know that kind of sounds stupid, but I will get to the point. Alright. Let's see. Also, this is also a right angle too. Now, first of all, if you see this big triangle, well, you're getting it wrong because we can split this into two triangles. One right here and one right here. Now, what I'm thinking of what we can do is we can try to find a way to prove that this angle is the same as this. We're going to prove 5.2. We can go ahead and into the future. There's another postulate we can use. Let me try to find the postulate. It's far ahead. It's like in the postulate 10 or something. Postulates. Postulates, complex postulates. Oh, okay, we're getting near. It's actually quite near. Okay, we're getting near. Okay, theorem 5.10. Oh, this is not even near 10. Okay, so 5.10 slash 5.11. Side A of a triangle is longer than side B if A is larger than B. Alright, so what it's basically saying is, let's make a really weird triangle. So, this is side A, this is side B. Now, this angle, which is correlated to side B, has to be larger than this angle, which is correlated to side A, because of the theorem that we looked at. It's not a postulate, it's a theorem. I keep getting those mixed up, sorry. This is a theorem. Okay, we can use that to our advantage because if this has to be bigger, then that means anything correlated to B. So like if this was the same size as B, like if this was B2, then this angle would be the same as this angle, which we can use to our advantage. So if we know that CB and CA are equal, that means their angles are also equal. That is mind-blowing. I'm going to use that. Okay. So, A, angle, side angle, ASA. Boom. So these two triangles are exactly the same, which means AP would also mean the same thing as BP. AP and BP are similar because of their similar triangles. So, with that said, Now here's the fun part. Here we go. The fun part. Since we have both both requirements to show that this is an angle bisector, then we can proudly say CP is the angle bisector of AB. P equals B. P. Ladies and gentlemen, we got him. Thank you all for watching and bearing with my pain. Sorry, it's been a long time since I've done this. It's summer, where you can just relax and forget everything. I had to go back and crack open my geometry book for you guys. Make sure to leave a like, comment, and subscribe. I think I said that before, but I'm just going to say it again because why not? It reminds you. Alright, guys. See you in the next video. Oh, yes. I forgot to use my calculator. I think I I should do some fun calculator sounds before I go.